So, what does the network of the future actually look like on the inside? I mean, really, under the hood. Today, we're going to pull back the curtain on 6G and Open RAN to see exactly how a futuristic holographic call comes to life. Let's jump right in. All right, let's set the scene. The year is 2035. You're in a bustling city, and advanced tech is just part of the landscape. We're going to follow a user, let's call her Horizon, as she makes a holographic call while walking through a park. Now, for this to work perfectly, without a single glitch, the network can't just be fast. It has to be incredibly smart. And that's really the big question, isn't it? How on earth does a network handle the massive, and I mean massive, data of a real-time hologram, predict a person's movement, and guarantee a flawless connection? Well, to find out, we're going to follow a single packet of data on its journey through the 6G O-RAN architecture. Okay, our journey starts right at the edge. This is the very first moment Horizon's device talks to the network. This is the physical layer. You can think of it as the network's eyes and ears. This first piece of the puzzle is the Open Radio Unit, or ORU. Let's give it a name, Lumen. Lumen's whole job is to act as the network's senses. It catches the raw radio waves flying through the air, in this case, super high-frequency terahertz waves, and its one job is to turn them into a digital stream that the rest of the network can actually understand. And it's not just sitting there waiting. Lumen is actively doing some really complex stuff. It's using digital beamforming to lock onto Horizon's device with pinpoint accuracy, filtering out all the noise, and then doing that crucial first conversion of the signal. Honestly, this is the foundation for everything else that's about to happen. And the sheer amount of data flowing through here, it's just staggering. To get this raw, digitized information to the next stage, the connection, which is called the optical front haul, it has to handle speeds over 100 gigabits per second, and with almost zero delay. That's the kind of power you need for 6G holography. So this signal is now digital. The data packet travels to what I like to call the network's real-time brain. This is where all the high-speed processing and some serious intelligence comes into play. This is the Open Distributed Unit, or ODU. We'll call this one Fusion. So if Lumen, the ORU, is the senses, then Fusion is the part of the brain that does all the heavy-duty, real-time decoding. It takes that massive, messy stream of raw data from Lumen and it starts to make sense of it all. And Fusion is incredibly busy. It's basically turning radio chaos into digital order. It's taking in signals from a whole bunch of antennas at once. This is what we call a cell-free environment, and it gives Horizon a much stronger, more reliable link. Fusion's job is to decode the super complex 6G signal and reassemble all that data into neat, organized packets. Now, working right alongside Fusion is the network's agile AI, the near real-time RIC. Let's call it Nova. Nova's job is a little different. It doesn't process the data itself, but it intelligently controls the network, making decisions in microseconds based on what's happening right this second. And this is just a beautiful illustration of their teamwork. So Nova's AI predicts that Horizon is about to walk behind a building, right? Before it even happens, it tells Fusion to get resources ready at the next set of antennas along Horizon's path. And the result? A totally seamless handover. Zero interruption to the holographic call. It's like magic. So the key thing to get here is this. This AI-driven control is what lets the network achieve what's called deterministic latency. That's a fancy way of saying a stable, predictable delay of less than 1 millisecond. That, right there, is the secret to a perfect, immersive holographic experience. All right, our data packet is now processed. Its path is secure. Next up, it moves to the network's central command for some final prep work before it leaves the radio access network and heads out to the wider internet. So now we meet the Open Central Unit, or OCU. Let's think of this as Aegis, the network's commander. Aegis is in charge of two big things: managing the connection itself, all the control signals, and handling Horizon's actual data, making sure everything is secure and routed correctly. So right here, Aegis performs some final, absolutely critical tasks. First, it wraps the call in quantum-safe cryptography. This is to protect it from threats that don't even exist yet. Then, it maps the data to the right quality of service flow, and, this is super important, it assigns the call to a dedicated network slice called hyperreality. This basically carves out a private lane for the hologram, guaranteeing it all the resources it needs. Now, before we get to the last piece of the puzzle, it's really important to understand the two brains of O-RAN. We've already met Nova, the near-RT RIC. It's all about speed, making microsecond decisions based on live data.
Now we're about to meet its counterpart, which thinks on a much, much bigger scale.
And here it is, the non-real-time RIC and service management and orchestration layer. We'll call this one SAGE. SAGE is the wise, long-term strategist. It's looking at the entire network, over hours, even days, to find ways to make it smarter and more efficient over time.
So what does SAGE actually do? Well, it does things like retrain Nova's AI models using data from all over the city to make them even better at predicting movement. It sets energy-saving policies for the whole network, and it even runs simulations on a digital twin, a perfect virtual copy of the network to prepare for future events. This is where the network truly learns and evolves. So there you have it. We've followed our data packet from the airwaves all the way to the core network. Let's just pull back for a second and see how this entire system works together as one. This table really brings it all home. You've got Lumen at the bottom handling the physical terahertz waves, then Fusion decoding the signal. You have Nova providing that real-time AI control, Aegis ensuring top-level security and quality with network slicing, and watching over it all is SAGE with its long-term strategic intelligence. You can see how each part plays a totally distinct but deeply interconnected role. And this really is the key takeaway. An Open RAN architecture for 6G isn't just a rigid top-down process. Because it's open, all these components, even if they're from different companies, can work together seamlessly. It really does function more like a living organism, sensing, processing, reacting, and learning in a completely coordinated way. Which leaves us with a final thought to chew on. We've just seen how an intelligent network can create a perfect hologram. But as this technology keeps evolving with a network that can literally predict, adapt, and learn on its own, what other kinds of immersive, interactive realities are we going to be able to build? The possibilities, well, they feel pretty boundless.